Draw the region bounded by x squared plus y squared equals 9 and z equals 3 minus y in the first octant. Okay, what is x squared plus y squared equals 9? I'm going to draw this separately because I want to show you how to draw it. Think in R2, what would this be? Circle radius 3. So you translate a circle, oh, z is missing, you translate it vertically, up and down. What kind of shape do you get if you translate a circle vertically up and down? Kind of a tin can shaped cylinder, right? So if you wanted the quick and dirty way of graphing this thing, it's actually a circular cylinder. The generating curve is a circle. But if you want to give it some perspective, you got to draw the end caps as ellipses, don't you? Because if you got right above it, it'd be a circle. But if you look at it from the side, it or slightly from the side, it looks elliptical. Go down, draw a copy of that same generating circle. So this circle right here has equation x squared plus y squared equals 9. It's just the height of the z has changed. And that's a copy of the circle down there. So notice I did it without coordinates, right? If you wanted to put in coordinates, I guess you would put 0, 0, 0 right in the middle there. And the z-axis would be the axis that cuts, it'd be the central axis of the cylinder. It would cut it in the middle. It'd go through the middle. So that's what that would look like. And then this guy, you guys know what this looks like. This guy is a plane. Okay, let's draw that plane. So I'm going to coordinatize this guy. Now, it's really important that I tell you where the positive x is. It's the guy coming out at you. Positive y is in the screen this time. Positive z-axis always goes up. Okay, z equals 3 minus y. If we graph that in R2 in this case is the yz plane. Okay, I'll say that again. Z equals 3 minus y is the plane defined by these two coordinates. So it's the plane of the screen. So let's graph that in the plane of the screen. Both the y and z intercepts are 3 here. So think in terms of just graphing in the plane. Plug in 0 for y, you get 3 for z. Plug in 0 for z, you get 3 for y. Okay, so I'm going to go out distance of 3 on both the y and the z-axis. Now, since I'm going to stay in the first octant, I'm just going to graph this line segment and not go any further. Now, what variable is missing? X. So I'm going to translate, that's a generating line right there. So this really, you can think of z equals 3 minus y as a cylinder with a generating curve that's a line. And I'm going to translate that generating curve parallel with the x-axis into the first octant because that's where we're interested in. That's what we're interested in. So if I just translate parallel to the x-axis, and then I've got to stop this somewhere, so I'll just go out far enough, and then draw a line parallel to the generating curve. And then to give it some perspective, I'll draw this triangle, so it looks like a wedge. So where I stopped it at is just a vertical plane that's parallel to the YZ plane. I don't even know what the value is. I didn't define what it is. And then this line, where is this line coming from? It's where the plane is this flat face here. It's where the plane intersects the XZ coordinate plane, okay? So this face here, this slanted face here, looks like a lean-to, is the plane we're interested in. But then we also want to insert a quarter of this picture in there because only a quarter. So if you made this the origin, so that you just have the part that goes of the cylinder that's above z equals 0, then the picture you get is a quarter cylinder. So kind of this part in red. So we want to talk about the region bounded by these two surfaces. So if I count off 3 on the x, because this thing's of a radius 3, so if I go out 3 on the x and draw the generating curve, which is just the circle of radius 3, I'm going to get something, so this is 3 also, I'm going to get a quarter circle looks like that. So that quarter circle is this quarter circle right here. That didn't show up very well. It's this quarter circle right here. Does everybody understand that? Now imagine translating that quarter circle, that's the generating curve in the first octant, up. It's going to intersect that slanted plane, isn't it? And that's going to help define the boundary of a solid region in the first octant. So long story short, how's it going to intersect? Well, we'll just take this edge as coinciding with this edge right here. So the back plane YZ is going to be a boundary. The side plane XZ is going to be a boundary. The real question is, what does the intersection curve of the cylinder, this circular cylinder, and the plane cylinder look like? It has to lie on both the plane and the cylinder. So the intersection curve is going to have to, in order to lie on this slanted plane and the cylinder, it's going to have to curve down to be on both and look like that. So the part of this object that we're interested in is, let me highlight it in green. So everything bound, so here's the ceiling. The ceiling, so we're talking about a 3D region. The ceiling is given by the top of the plane. There's a side wall given by this funny looking object here, the top edge of which is defined by the curve where the plane and the cylinder intersect. So this is like a curvy wedge in green. You can erase all this other stuff. All this other stuff is irrelevant now. So what we're really talking about is the region bounded by this curvy wall here, the ceiling on top given by the plane, the floor is given by the XY plane, the back wall is given by the YZ plane, and this side wall is given by the XZ plane. If you didn't get all that, don't worry, you're going to see more of this.